discussion over there. But I'll flip back to here when, I need to talk more at the end for questions so we can chat face to face. Okay, hopefully this is it. Hopefully everybody's seeing this. Oh, thanks for yeah, dude, you like that? You like my goatee? So no echo now. Is everybody good with echo? Okay, let's get started. So this is Power Python for development from Maya. It's similar to the talk I gave at GDC a couple weeks ago. I added a little bit more time. So I add a little bit more stuff we'll talk about. I'm also not limited to time. I was limited to 50 minutes, so I talked really fast. This time we have no time limit, and I added a little bit more kind of pseudo code to look at. So I'll take questions as I go, and I'll try and answer them. Looking at pseudo code and speaking a little bit slower means we could go, an hour and a half or so. So hopefully that's okay. I mean, if we could go like 2 hours, but I'll try and keep it down. So for those who want to kind of skip to the end or whatever, luckily we aren't all sitting in the auditorium at GDC, so you can just take off or whatever and come back in an hour and see, the last half of the talk. And okay, we're gonna get going. Roxy, go over that way. That way, Rox. Sorry, my dog just came in. Roxy, go ahead. Okay, let's get started. Okay, we're gonna cover. We're gonna go over my background real quick. Hold on 1 second. Sorry about that. Okay, we're going to go over my background. We're going to take a quick poll, and you guys can type in the chat to respond to the poll as opposed to holding up your hands like they did in the auditorium. I'm going to talk about the takeaway you're supposed to get from this talk, and then we'll get into the meat of the talk. First third will basically cover the difference between MEL and Python for those of you who don't use Python much yet. Second third will be the differences between Maya Python and PyMEL. And the third bit will be covering some cool IDEs, integrated development environments, and debugging. So that's what we should cover. Okay, so I've been at Sony for a long time, worked with Chad over there and Brad in different ways. My specialty is Maya and Motion Builder, and I tend to be reading a mocap guy and animation guy. Okay, so I've given plenty of talks at GDC and other master classes. There's the one you want to note there is the one on top. So despite all of my disparaging remarks, I'm going to say over the next bit about MEL. Remember, I'm MEL's biggest fan. It's how I got started, and I did a master class on it way back when. So remember, I still love MEL, but it's a little old and out of date. Okay, so this is where I would take a poll and I'd see who's holding up their hands. So hopefully, if you have access to the chat window here, you can maybe say like, so I want to know how many people here use Maya. So maybe you can just type Maya yes or Maya no in the chat window, and I'll try and watch it all go by. I'm presuming most people here are all Maya users. Great, awesome. So even if you aren't Maya, this talk mostly kind of covers really Python to be used on any DCC app, so or any other language that's like Python. So if you're a Max user and you use C#, this kind of stuff will still pertain to you in many ways. Okay, so how many of you are scripters, done some scripting, and have done MEL or Python? So maybe you can do scripter and then MEL or scripter Python or scripter PyMEL for or any or all three by your name. So you can tell me what you scripted in. A lot of scripter MELs, cool. Whoa, PyMEL, a little bit of everything for some people, a little bit of PyMEL. Excellent. Cool, thanks for that feedback. Okay. And then how many people have any object-oriented programming experience? Python, of course, is OOP, though you may not have used it. So if you have, do OOP yes or OOP no. Basically C++, Java is all object-oriented. Okay, there's a couple no's, a lot of yeses. So far, 50-50, no C++. Okay, that's good. Good. And then we don't really need to answer the next one, but essentially API SDK, that means, using C++ to write plugins for Maya or Motion Builder or some other DCC app. If you want to, you can chip in and say API, yes or no. For most of us, it's beyond what we have to do, thank goodness. Some people, though, yes. Cool. No coding, API, no. Great. Okay, that's perfectly fine. That's what I expect. But what it probably means is you've never used an IDE, which was what we're getting into now. So most of you guys use scripting. Or then there's IDEs like Visual Studio or Eclipse or Wing for Python. So why don't you put the name of your favorite script editor if that's what you use most of the time, or if you've used an IDE, list that. Some Eclipse users, excellent. Some Wing and Ultra edits, some notepads, Goods, Crimson, nice. Okay, yeah, a little bit of both. Some Eclipse users, excellent. Okay. That's all good news. Excuse me. Okay, so that means that you guys are the correct target audience. We're looking for a little bit of Maya scripters or programmers. Ideally, you've done some advanced scripting, and ideally, you've done lots of MEL, and you've tried some Python or PyMEL. It looks like that's most people here. So hopefully, you guys will get some good stuff out of this. What I want you to take away from this is that Python rocks. I love it. It's a killer tech art scripting language. Especially. And the basics here is if you want to have absolutely superb Maya development, MEL has its place, API has its place, but for the bulk of our work, PyMEL with an awesome IDE like Eclipse, and or using one like Wing with the debugging in runtime is a super way to develop Maya. And I'm going to talk about that for the next hour. And all of this stuff is usable by you guys as soon as you can get it up and running. So here we go. Okay, so I'm going to, in between these major sections here, I'm going to show some basic use cases. And so the first one I'm going to show is the genetics tool. So this isn't actually a PowerPoint. I'm doing a PDF, and then I'm going to, because PowerPoint didn't want to work through Vocal, so I'm doing a PDF, and then so for the movies, I have a good dozen or so movies that show demos. I'm just going to manually hop over and play them. So here is the movie. So let's see if we can get this playing fine. This should work okay. Okay, so this is the genetics movie made by my buddy at Sony Online. Where I work, and this is our genetics tool. So what you're seeing here is this wearable system he has here, and he clicks in the UI over there, different character races, and it does all the stuff behind the scenes, and it brings in the guy, and it uses wrap deformers, and it changes the armor, and lets you save it all out, right? Really cool tech art tools. But the key thing here is this UI on the right. That's all Qt, because Maya 2011 is all Qt. And so that kind of UI that's basically PyQt, Python wrapped Qt libraries. You can't do that kind of UI with MEL. I mean, I've seen people kind of get close to it, but you can do really cool UIs with Python and Qt. So that's an example of a mock-up there. Okay, I think I can just go like that. And here. Okay. And I have another movie here. This is a rig I'm going to show, a build rig. So this is, you're going to see a rig build going on here. So what's happening is I'm highlighting a bunch of, by the way, that whole tool was written in Python. So this is the kind of cool stuff you can do in Python. So right here we just highlighted all this code in the script editor, and what you're seeing and doing is automatically rigging up this dragon bird. And it's a build code, and it's doing all this procedural rigging, and it's importing in all the controls, as you can see there. It's importing the skeleton and auto binding it and rigging up the whole character, and boom, it's done. It just rigged up the whole guy in 30 seconds. It has IK legs on, and the rig is fully working. So that's all written in Python. It's a big modular system of coding, Python rig code, and it could all theoretically be done in MEL or even regular Python, but it's all Python and PyMEL and allows you to do really cool stuff like that. So there's just a couple examples and use cases of some of the stuff you can do, especially with Python and PyQt. Okay, so now we're going to get in and talk about MEL versus Python. About half of you kind of already have dabbled, or more have dabbled with Python. And but for those who haven't, this is the difference. So moving from MEL to Python is pretty much a no-brainer. MEL is a great place to start. Good way to start learning scripting. But I'd recommend committing a couple weeks and learning a new language. The second language is a lot easier than the first. You'll pick it up really fast. Python's a great way to go. It's really, it's used highly in the industry. It's also named after, one of the greatest comedy shows from England from decades past. So Python, the string methods alone are worth the price of admission. They are awesome. You can do all kinds of better matching with the regular expressions module. It's way better than the GMatch stuff in MEL. You can here's a little bit of pseudo code right there. Hopefully you can see that. But so you can use searches and search inside of variables for stuff, and then you can do real powerful regular expression searches and do this stuff where you're looking for 9 and anything that fits in this realm, and you're searching this variable. So super easy to use at first, but it can go super powerful. So regular expressions is great. There's hundreds of methods essentially attached to the string class, essentially the string objects, and the replace one is super handy. There's essentially MEL commands that do this kind of stuff. They just aren't as simple and as easy to use. So just being able to swap out one word for another in your file paths especially is helpful. So Python also has not just double quotes like MEL. So on this top version here, you see MEL, where if you want to put quotes around something in a string, you got to use these escape characters. But it also has single quotes. So if you look down here in Python, you can put single quotes around the outside, and then the double quotes inside are gonna put quotes around the word world, but you don't have to use escape characters. There's also triple and quadruple quotes. So what you see down here is triple quotes and single quotes in here and double, and those are really handy for, you don't have to use the escape characters, and they become really handy for stuff like this. So if you've ever had to do those pesky system calls where you're creating a command that you got to do like an OS system call on, and you're building up this big DOS command, but the DOS needs to have double quotes in it, but your escape characters are messing it all up, you can use like triple quotes here, as you see. This is like this big command I had to make, and you can use triple quotes on the outside and double quotes on the inside, and Python lets you deal with as many of those different things as you need. It also has really nice formatting. So the concept here is, when I do print, instead of putting the number 5 right here, or my file name variable putting in here, what you do is you can use this % thing to format what's going to hop in here, and then you use this % here, and you can line up all your variables here. And what it does is it takes these and it slots them into your print statements, or your string building essentially, and this is your answer here. So there's a whole bunch of these formatting that at first seems like it's kind of a pain, but it becomes really handy. It's just another handy thing about Python. So to summarize, the string methods are awesome. Great way. You can slice up all the strings in a whole bunch of different ways. The regular expressions are great. All the different quote options are great. And all the formatting is really handy. There's 50 other cool string methods for string objects too, but all of this stuff is, 80% of what we do in MEL and scripting anyway in Maya. And so already you're going to never want to go back to MEL once you start using Python for string manipulation. All right, how are we doing so far? Everybody good? Everybody hear it? Pace going okay? Hope so. Okay, so Python's also, it's real clean. So the idea is there's lots of white spaces. For some people, this becomes an issue. So it's white space dependent, meaning you can't just kind of format your code however you like to in MEL. You have to indent and dedent for loops and whatnot. Some people find this an issue. I'm fine with it. I kind of think it's better. It really cleans up your space. You don't need to use semicolons or dollar signs like MEL right here, right? This MEL here. This is the same thing. You just have basic variables. It's dynamically typed, which means you don't have to declare what type. And it doesn't have a lot of syntax, so it gets really clean. It's nice that way. All the file system packages and modules in Python are really powerful. So it has this shell utilities one where you can get all kinds of directories information, and it has an os.path and these path and os walk. These are just different modules that let you scrape through directories and read files and do pretty much anything you'd ever want to do with your file system. MEL is pretty lacking on that part. Python's pretty much built for it. I think Perl is maybe the other language that's really designed for that too, but Python is nearly as good. So here's an example down here. Like this OS walk is awesome. You basically say, you have a for loop and you're essentially iterating, walking through your temp directory, and it's going to return the top directory, all the directories inside of that, and all the files in all that directories. And you can just do stuff from then on out. So really good for searching. Somebody's saying glob modules, awesome too. Tons of stuff like this. Okay, the lists are really cool. They're essentially equivalent to the arrays in MEL, but there's a bunch of different kinds. There's actually lists and dictionaries and tuples, but lists are the basic array type. They're really cool. You can slice them and sort them, and you can add to them, and you can nest anything you want into lists. You can nest dictionaries and lists, or lists inside of lists, or anything you want inside of anything. And so here's just kind of a quick example, a MEL list, right? You got to declare it first. You go through a for loop. And then you got to explicitly point to the spot and add into your array, your new word or whatever you want to add. Or in Python, you're just iterating, you're using this range and going 0 to 10, and you can use this append because it's object-oriented. We'll see this later, but you can basically just start your array right here and just append to it, and it just adds into it. And we're using a little bit of that formatting here. So little things like being able to just add on to it and not having to explicitly keep track of where I am on my list. Really handy stuff. So Python's functions are polymorphic. This means that global proc, right, global procedures or procedures in MEL, that the equivalent to that in Python is functions. They use the word def or define, I think, define function. But they're polymorphic, and this means that it can take any kind of different number of variables, and you can have a different number of arguments. It's not so restrictive as MEL. Also, you can return anything you want. This is one of the huge factors when you'll be writing Python for 3, 4, 5 months, something like that, and you'll realize that you can return from your functions whatever you want. MEL is pretty much just a single variable or an array, right? Now, theoretically, you can use weird string concatenation to try and get an array of arrays, but it's a pain in the butt. In Python, you can return a list that's just infinitely embedded with whatever information you want on it. That becomes huge. What it meant was all that time we were writing MEL, we were really limited to kind of the scope and complexity of the procs, the procedures we were making, because you could really only return a couple things. But with Python, as well as the OOP, which we'll talk about later on, you can return and store all kinds of data anytime as you want, and it just explodes all that stuff. So Python, it also has plenty of libraries for anything you want to do with XML, right? You want to soon your complicated pipelines want to start datafying all your stuff. That just means not hard coding values, but putting it all in XML or data files. Python has all kinds of modules that let you read and write XML super easy and fast, whatever you want. Same thing with SQL. If you want to write to databases or read from databases, there's a bunch of Python modules. They're all free, stuff you can download, and it talks with them really well. As well as pretty much anything else you'd want it to. But those are the main ones we tend to use in the game business, especially. There's this cool stuff. So the other neat thing I found was list comprehensions. It's a fun Python trick. It's essentially syntactic sugar, is what they call it, and it's just cool code tricks. So here's a good example. So here we have some MEL code, right? We've got an array. We're iterating through everything we have selected, right? ls minus sl is everything we have selected. We're testing to see if what that thing we have selected is a joint type. If so, or if we're assigning it into our joints array, and then we have to increase our iterator here, and then so essentially what you do is any joints you have selected is throwing it into a joints array. This down here is called a list comprehension in Python, and this is doing essentially the same thing. So what this is doing down here is essentially saying for everything you have selected, test to see if its object type is a joint, and if so, toss it into the beginning, and if it works here, then throw it into an array, and then you get, or a list in this case in Python, and out comes a list called joints that does the exact same thing before. Everything you have selected, checks if it's a joint. If it's a joint, it throws it into the list called joints. So This is a little bit cryptic, this code here, but these are fun to write. But here's an example. There's your PIML code. This is the Python code that does the same thing. Pretty good argument on how and why Python is a lot better and faster for doing pretty much anything. All right. Okay, so other features. The logging module is really cool in Python. It's pretty much going to replace anytime you're going to want to print or do any kind of debug print statements in your code. I think I show an example of that working later in Maya, actually. You can also compile Python to a compiled file, a PYC file, or there's programs that allow you to compile to exe. So if you want to release something on high-end 3D or Creative Crash, or you want to sell something, you can compile it, and then it can't be reverse engineered. And then of course there's the web, the Oracle's just filled with resources and tutorials. It's a very prevalent language, especially in our industry, so you can't go wrong there. So this is the key feature for Python, though. It is object-oriented programming, and what that means is, so luckily a lot of you have done some OOP. For those of you who haven't, don't get too intimidated. But what it means is you have classes and instances. You instantiate classes and you do stuff on it. It has data abstraction and encapsulation. That just means kind of compartmentalizing your code and reusing it in many different ways. It has inheritance, which means you can inherit classes, which means you can organize your code in simple forms and then kind of expand onto it. It has polymorphism, which means it's really forgiving and flexible in the way you defined what variables come in and out of it. Everything else you get in every OOP language. Now, you don't have to use OOP to do Python. You can just script Python away and not really be too concerned with, classes and instances. It looks a little bit different at first, maybe, but for the most part, you can just script it. The cool thing is whenever you want to, you can start using classes and using OOP. So when you do start to use OOP, it may seem a little bit complicated at first, but it's fun. It's fun to use, and once you start to get it, it can scale to be really, really powerful. I mean, you can do just about anything, especially anything that all those C++ programmers do, anything all the engineers and coders do at your company. The only difference is it's not super fast. It's not compiled down into something super fast. But for what we do, we're not usually geared on performance. We just want utility. But the thing is, with OOP, your utility can expand to pretty much anything you think of. Okay, to summarize, we'll wrap up the Python and PyMEL section. String methods, super fun, clean and readable Python is. All the lists and all the nesting is super powerful. Logging really becomes really handy, and of course it can scale up and do OOP in classes. Okay, so I'm going to hop into another use case. So hopefully at this point everybody sees it's probably worth it to spend some time learning Python over your MEL. You won't go wrong there. Let's get into so there's this thing called the CV exporter. It was written by a guy named Chad Vernon. It's essentially a DirectX exporter. I think there's a link right down there where you can download it. And so because it's Python, it's you can look at it and reverse engineer it. This is a good way to get help, especially on Maya exporter. If you have to write Maya Python exporters, this has great examples of vertex scraping, i.e., looking through all your vertices and getting all the information your game engine is going to need. There's lots of Open Maya and API stuff in there, which is essentially because Python essentially lets you call a lot of the C++ API stuff in Maya. So I'll show you a bit of that real quick here. There's some really nice use of classes as data containers, and it's really high-level code. So I'm going to hop over to my BB edit right here, and I can make this a little bit bigger, but hopefully most of you can see this a little bit. So here's the code, here's the script. Great big script, all kinds of neat stuff in here. And so I just hopped to this get mesh info function. This is all Python, but this is pretty heavy API Python. So you'll see here you've got all this FN skin cluster. This is Open Maya calls. This is all Python. It's non-compiled, but it's using MFN skin cluster. This is API stuff. It's scraping through and getting the skin weights and creating all this data here. So great example of all kind of code. If we hop up here, let me show you these other classes. So he made classes. So here's what he has is an XMesh class, and these are all attributes that's part of this class object. And when he instantiates this, he's essentially, this is all the type of data he's collecting, and he's going to spit out to his exporter. You got vertices, normals, binormals, all kinds of stuff. And then what he does is he instantiates this class, and he goes through your object that you're going to export and fills up all this data. So great examples of classes. Quick side note: I'm not classically trained. I don't have a computer science degree, so it took me a long time to learn about object-oriented programming and why you would use a class. And my first hunch was that you use a class like this as a data container. You'd essentially use it to just kind of store a bunch of data. And so here's a good example of that. I soon realized that then you can attach methods to these classes and you get all kinds of power, but added onto it. Here's a really cool method for those of you a little bit more advanced. Or what this is he's got an attribute attached to this XMesh class. So when he instantiates it, and this attribute is an MFN mesh API function. And what these are is these are API kind of utility functions that you run on Maya, like mesh objects. And so later on, I think where I had it before, let me go ahead and hop down there. Get mesh info. So check this out. When he's getting the mesh info, he's passing in the object he's going to try and work on. And this is a little bit advanced for those of you who don't understand it. Don't worry about it. And then he just uses this FN mesh. That was essentially an attribute that was pointing to that MFN API object. And then he's calling MFN API methods to this. So really cool stuff. Okay, enough for that sidetrack. So pro level code, really good way to reverse engineer stuff. There's tons of stuff out there. So if you need to write your Maya, object exporter and you want to use Python, go to something like that, and you've got all the code you need to do there. And it's a great way, especially to learn API stuff, which I haven't really even got into. I tend to use more PyMEL, which also bridges to that. That brings us to our next topic. So the Autodesk implementation of PyMEL or Python into Maya was great. It was a really good first start, but it was really only kind of half baked. And what happened was Chad Vernon and some other fellas decided to write PyMEL wrapper, and it really takes it to the next level. So most of you have probably heard about PyMEL. If you haven't, and you're thinking about getting into it, you really want to get into it. If you better take it, it's time to take it seriously, commit some time to it, and ramp up to it, because you won't regret it. Autodesk essentially blesses it now. It ships with 2011. They ship PyMEL 102. It doesn't really have anything to do with MEL. I think I explain it in the next slide. It's not compiled. It's Python. It's strictly just Python, really. It's open source. It's free. It's up at Google Code. You can add to it, contribute to it. You really, it's even if the guys stop writing it, it's still open source, and you can use it and support it yourself. So there's not really a big bunch of deal there. And what is the difference between these languages? Well, here I try and explain it a little bit. So MEL, as we all know, stands for Maya Embedded Language, right? All of Maya is built off of that. That's what makes Maya rock. And then they included essentially a Python wrapper around their MEL and some of their API stuff. When we're going to refer to that as Maya commands at this point, because this is kind of the Python nomenclature, and Maya commands is essentially standard Python calls to the Maya commands. And then there's PyMEL, which is really a Pythonic Maya language. And a lot of people don't really, fully grok what that means, and that's why I, wanted to give this class is to get people up and running. And you won't really get it, even everything I'm saying, until you start to use it, and then you will realize that it's the true implementation of Maya Python, but really just kind of Maya in general. So here's the key difference. Maya commands is really just MEL in disguise with more white spaces, in my opinion. So MEL, like Maya commands, is like command based. So in MEL, you have a command, object you're going to act on, and any flags to it, right? Duplicate my cube, and twice or whatever. Whereas PyMEL, it's really object oriented. It's based on classes. So we use this kind of syntax. You have your object, your cube. You use this dot syntax, and then you get to run a function on that, or the command on that. And you can use the term function or method. This is universally use, and basically means it's a command that's kind of attached or coded especially for your object, and you can still pass in flags to that. So here's an example. An example of a basic OOP and the idea of a class and creating an instance and using a method. So we want to create an object of a joint type class. So this right here is the joint class. And classes usually start with a capital word or a capital letter, and it uses and with parentheses. And when we use that and set that equal to my joint, we've essentially created an instance. Now, I was hoping to kind of do a real quick preview of OOP and classes, but I had to cut it out for GDC. I don't have time to do that. But for those of you who are close, this is kind of this is a 5-minute talk about classes in OOP. That's normally covered in a 6-month course or whatever, or whatever John Newman pointed there at the MIT. Okay, so basically when we run this line of code, my joint is now an instance of a joint class. So this joint class, this is defined somewhere, and it makes a joint, and now I have a joint, and now that I have that joint, I can use this dot, and I can run a method on it. Basically, it's a command attached to it with the parentheses, and it runs the command. And of course, I get a result of root if that was the name of my joint. So this Pythonic difference, this little bit we've seen here, this fact that you use an object-oriented and a method, and this Pythonic difference, is the most important difference between PyMEL and regular My Commands. It is huge. PyMEL does a whole bunch of stuff, but this is the killer app. What it means is, and I'll iterate this more later as we go throughout the class, but what it means is all pertinent commands or functions are attached to the node as a method. I.e., any node, when you have a node, anything you want to do to it, you press dot, and then you've got a method that is going to work on that node, whether it's a join or a mesh or list object or whatever. So I'll illustrate that more later. But you take that and you combine it with a good IDE like Eclipse with PyDev, and those things do code completion. And what it means is you're going to have your object, and you press dot, and it's going to do code completion. It's going to list all the methods that you can ever do on that object. And this is huge. I'll show you more examples, but this is just awesome. So if you want to find all the methods and you don't have an IDE, you can still just do it in your script editor in Maya or whatever. There's a Python command called dir, and you can do it on your instance object, and I'll give you a full list of all the methods that you can do on that. So for example, for your joint, if you just do dir in my joint, it'll list all the methods and attributes that are on that object. If you want it to look a little bit prettier, you can put it through a for loop, and it'll print it vertically instead of one big list. So I'm going to keep reiterating this difference here. Let's do another example, something a little bit more readable. So the Maya commands, the simple Maya Python implementation, is we have our list relatives command, and in Python you use parentheses, and this is the object you want to list relatives on, and you pass it a flag, and when you do that, you're going to get your result. But in PyMEL, because it's an object, you get to take, instead of my joint being over here, you take your object and you use dot, you use a list relatives, that the command is attached to it afterwards. Call that a method. You can still pass in flags. Not such a big deal, just to reorder. But then PyMEL has tons and tons of convenience functions and methods. So, and you can add these too. You get to make all these when you do OOP, or you can add it to PyMEL. The point is they've made a convenience method attached to the joint object, or it's essentially the transform object, which the joint inherits from. But you can use myJoint.getParent, and it's the same thing. GetParent is a wrapper method, and it's the same as list relatives with the parent argument passed to it, and all three of these are going to return the same thing, root. But as you can start to see here, this becomes a lot more readable than this, right? I mean, you guys are all good scripters, so you know what this is, but new people coming in, or you need to remember thousands of commands, it's hard to remember exactly what this is every time. But with PyMEL, it gets really easy. You just instantiate your joint, and you do dot and dot get, and it starts to fill in for you. I'll show more examples of that for a bit. And so this becomes, this is much more readable, like I said. And readability does count. So there are these things called PEPs in Python, or Python Enhancement Protocol. So Python's an open source language. It's free. Anybody can write to it. But since the whole world is contributing to it, they don't want it to look like a big mess. They want everybody to kind of make it look the same. So that's what these Python enhancement protocols are. They're protocols to add to Python. 8 or 20. One of them is called the Zen of Python. It has 29 little kind of Zen koans about how Python should look. 29 out of 30 because, of course, it's Zen, and in Zen you can't have completion, etc., etc. Anyway, there were cool stuff like beautiful is better than ugly, sparse is better than dense, and Zen koan number 7 is readability counts. So this isn't to be underestimated. It is important, especially when you're having to go back and look at your old code, especially if you want to look at somebody else's code. If you have to go back and look at a bunch of old MEL, or especially Maya commands, it's big and bloated and it's hard. It's a lot easier to actually read in PyMEL. PyMEL is a little bit more English-like. So remember that as you start writing in PyMEL. You'll see it's much more. Here's another example. So the other day I came across the idea, and so I needed to do something to an anim curve. So I had an animation, and I have an anim curve node in my hypergraph in Maya, and so I needed to get some information from my keyframes. What was the beginning and end? How long was this animation? And I couldn't remember what command it is. Is it the timeline command? Is it the keyframe command? Is it I forgot what it was. So but in PyMEL, luckily, I just went straight to the documentation, and there is an anim curve class. So everything in PyMEL, they pretty much have a class for everything. And it happens to be derived from the Open Maya anim. So it's essentially an Open Maya. This is essentially C++ API or Python API wrapped by PyMEL. So what I did is I instantiated my anim curve class. I passed in my anim curve node that's right there in Maya as the name, and what I get out of it is an instance that I've called AC, and now I have a PyMEL instance of that node in Maya, and now I can do whatever I want to that. I can run methods on it. So I did AC dot, and I started to do get, and sure enough, a method came up called get time, and I said, well, I want to do get time at the 0th keyframe, and it passed me the first frame of where that key was. And I wanted to get the last frame, and I did AC.getTime. What's the last frame? I don't know. I can't tell what the last frame is because I don't know the number of keys in it. So I did AC.num. Sure enough, there's a number of keys method attached to it, and I just subtracted 1 from that, passed that into time, and I get the last frame. So it only took me, 3 or 4 minutes to code that up because all I had to do was find the class, and then there were these methods attached to it. And here's the old way. This is my commands way, right? So first of all, I have to figure out what command I'm going to use. It happens to be the keyframe command. If you remember that, you have a better memory than I do. I can't remember all this stuff, but you go through the documentation, you find keyframe. Then you use, you pass in the object you want to work on. You got to pass it a query. You need the key, whatever, key index, something. And that really just gives me my last key. So my first frame, I got to do keyframe. I got to once again act on the object. I need to pass in this funky syntax, and I get my first frame. Last frame, I got to pass this in. I got to pass in index with this last thing I got. And sure enough, so it's a little bit more bloated. But here's the trick. My commands is indeed MEL in disguise. Look, this is the MEL code to do the same thing, right? Keyframe query. Here's what we just saw. This is the Maya commands code. Same thing if you look at it, right? Maya commands is just MEL in disguise. It's still this old architecture of commands and passing in the object and using this query stuff. And it's pretty much bloated and out of date. So hopefully that kind of shows you that we want to move away from Maya commands and move up into something a little bit better and faster. So more PyMEL. It's super fast to get access to attributes, right? Your standard Maya commands, you got to figure out the command. Oh, it's a get attr command. I want to get the translate x attribute on my Maya joint. I'm using this little Python formatting here. PyMEL has this really cool functions. You just put your objects, you do your attribute .get, and it gets it. Much easier to read. You can do the same thing for set. Accessing the attributes, all the whole attribute class and all the wrappers they did for it is really cool. It's really easy to read, right? So here we have a sphere, which we put it in. It's this little object called S. You can, check if the visibility is keyable and it's not locked, and if so, set the visibility and unlock it, and then print the type of the attribute. So these are a couple different ways to use the attribute stuff in PyMEL. The API hybridization. So PyMEL and like we saw in that anim curve class, it tends to use lots of API classes. Oh, actually, this is the DagPath stuff. So this is awesome. So When PyMEL became mature and went to 1.0, what they did is the Py node underneath the hood changed to start to use the API DAG path. And what the API DAG path is it's like a pointer. It's like an API pointer to the whatever object you have in memory. And when that pointer works regardless of what the string name of your node is. So if you change the name of your joint or your mesh or your local whatever, if you just store that as a string in MEL or Maya commands, you're going to lose it. That variable's pointing to the wrong thing. But if it's a Py node, if you have an instance of it and the name gets changed, especially when you're doing some re-rigging or something like that, the instance is still going to point to the right spot in memory. This is a huge plus. I think Hamish, who's still reluctant to kind of even use PyMEL, admitted recently that this is one of the PyMEL's biggest advantages. And so this is really handy for rigging. Like I said, when you're doing rigging through code, you're going to be reordering stuff a lot, and the hierarchies are going to change, and therefore your names of your nodes are going to change a lot. It's hard to keep track of all those. If you have a PyNode instance of your objects, it'll keep track of all of that for you. Especially the shape nodes. You guys know shapes you have a transforming shape node underneath, and those shape nodes are named something really weird. That's usually like shape 1 at the end of it. But if you name your object, it changes the name of that shape node. It's really hard to figure out what it is, procedurally. So this is really cool stuff. It's all underneath the hood. You don't have to worry about it. Like I said, there's all kinds of API wrapped stuff underneath the hood. PyMEL also uses the Niterator components of all the API stuff. I was going to show an example of this, but I'm pretty late already, so I'm going to have to kind of skip that. You can also do virtual classes. So they provided a thing where you can take your own nodes or some of the few nodes in Maya that don't have Py nodes representing them. You can subclass. You can essentially make your own Py nodes. So we use this network node quite a bit and the meta rigging concept, which I'll talk about in a little bit as well. And it's a Maya network node. It just holds data and connections, but you could essentially turn that into a Py node if you want and use all kinds of inheritance if you need to. It's a good example. Sorry, I don't have time to demo that real quick, but I probably will release on my blog some source code to do that. Seth Gibson helped me out with this talk a lot, and he gave me some examples, stuff like that. I don't have time to cover, but I will. He said I can release that, so I'm probably going to put that stuff on my blog. So if you guys want to screw around with that kind of stuff, there's also really cool MEL wrappers. So if you still need to make MEL command calls, because sometimes you still do, especially in this case, the skim weights was a plugin we had to do, and there wasn't Python calls to it, so we still had to call MEL to do it. So if you're going to use your standard Maya commands, you've got to use this eval thing, and you've got to build up the name of the command with all this backslashes and quotes. Now Python's a little bit cool and handy, so you can use this formatting things and single quotes, and so you can make it a little bit better. But PyMEL has this really cool function essentially called MEL, and you just put dot. In this case, it's the MEL function name, and you don't have to put any quotes around it or eval it. It looks like Python, and then the arguments you want to pass to it, you just use standard old Python arguments. So essentially, it kind of converts a MEL function into, you can write it just like you would in Python. It's a cool little wrapper for when you need to do that. MayaPy is the standalone Maya executable that lets you run Maya outside of UI mode and command line, and it lets you run in essentially a Python interpreter in there too, so you can run all kinds of your Python scripts and do batch processing. It's a little bit hard to get it to run, especially the whole environment. PyMEL has all these functions. When you just run MayaPy executable and you import PyMEL, it's real smart. It'll look at your MayaEnv and parse it and source a lot of the Autodesk scripts it needs in your user setup. So it makes all that stuff really easy for you too. They also fixed a little bug in logging. So you guys heard where I mentioned we're going to get into the demo. So hopefully you're going to have to, just have to see simple slides here real quick. The logging functions are really cool, but the way it outputs to Maya script editor is a little bit buggy. So PyMEL has this Python logging module that fixes the Maya output a little bit and makes some other things that are real convenient. And this is how it's called right here, and I'll show a demo of it. Essentially, just from PyMEL, you import PyMEL Logger, and right there you have essentially a logger object. For those of you who use the loggers, you have a PyMEL Logger, and you just do .info. So this is kind of what you want to do instead of print statements. You don't want to use print. You want to use .info, which is the equivalent of print, and just print out your data here. And instead of warning, you want to use .warning and do that right here. And I'm going to show, oh yeah, and then there's all the logging is really interesting stuff. But then there's all these levels to logging, where you can set what level you want data to log to and where, and what kind of, how you want it to log and where. And you can access it all via code, but PyMEL made this cool logging control menu, and by just importing it and running it with this code here, which I will show, it lets you access it all from Maya. So I'm going to hop over to my movie to demo this a little bit for you guys. And it is, let's see, the logging. Wing refactor logging control. Here it is. Okay. So what we've got going here, I'm going to adjust my screen capture window here a little bit so you can see it. This is a little bit funky. Hopefully you'll see it there, kind of. Okay, so up in the right corner, oop, we don't want to go that high with it. Okay, so on the left we have Maya, on the right we have a script script editor that we're going to start to see it print out to eventually. So what happens is I run that code you just saw there, I initialize the menu, and what it does, it creates a logging menu that you can't quite see off the screen, but it's right there in Maya, and what it does is it lets you access all the different logging levels and set them right there from the menu. So either you have different levels like debug or critical levels here. So what I'm doing is I do use my PIML Logger.debug, and because the level wasn't set to debug, it didn't print out anything. But because it was set to info, it did print out down here. And when you print out warning data, it colorizes it like Maya likes to do it. When you do an error, it colors it red, and critical is even more critical than error. And so what I'm doing over here is I'm going over to my logging control and setting the level to debug, which is what this means is whatever level you set your debugger to, all your print statements or all your logger statements from that level on up, i.e. more critical, will start to print out either to your output or to your file or email or whatever you have to do it. I don't have enough time to fully explain Logger, but those of you who've used it, you have quick and easy access. So now that I set it to debug level, now any code I have that has debug in it will print out like it did there in the window there. You can set the levels either via code and it updates in the UI, or you can update it in the UI as well. So also there's these things called streams, and what you can do is you can have it, instead of just logging to your output here, you can have it logging to a file handler. So you can attach a file handler string, and you can set the levels on that. So what we're seeing over here on the right is all that output I just actually logged to a file. So now that the file handler level is set appropriately, when your code is running and it's giving out warnings or info, it's writing right to this file. So this is a really good way for tech artists to have. And if you write this file to the network, then you can see all the errors all your users are having. We even have a set for critical level. If you have a critical error, then you can attach email handlers. You can have it right to a database or web pages or whatever you want. So what I'm demonstrating here is just PyMEL made it really easy and work real well with Maya, which is really cool. So loggers are super cool. Okay, let me adjust my screen capture window here a little bit. So PyMEL has also it has some UI wrappers like everybody else. Everybody's trying to wrap Maya's UI in a bunch of different ways. It has this window class, and it has these cool horizontal layout classes, and you can iterate stuff and add buttons, and it has some cool other functions in here. I'm running a little bit behind, so I'm going to have to kind of skip up through there. This was essentially a demo of creating some different windows and redistributing them, flipping them around on the fly, and disabling a bunch of buttons on the fly, but you guys will have to see that later, sorry. It uses this cool with statement. So the one thing nice about MEL is you can indent it and format it any way you want, just like this old code right here. Python is white space specific. You can't indent. It'll kind of error out. So when you're trying to make UIs in Python, Maya commands, it looks like junk. It looks like this. It's really hard to figure out what's going on. But PyMEL used this kind of with call, which is a kind of a weird advanced Python function, and it lets you kind of indent your UIs a little bit. So it makes that a little bit more readable. Last thing, getting almost finished up with PyMEL here. It has the path package automatically included with it. This guy, Jason, wrote it. It's included in Python 2.4 up really cool for paths, lots and lots of utility methods. I don't know about you guys, but good half, most of my stuff is importers and exporters and art pipeline, and most of that is like file paths, and I'm having to always parse and move and rebuild file paths. And with this class, you essentially instantiate your path, and you get all these methods, and it makes working with paths super simple. You get that free with PyMEL too. So you're thinking, PyMEL, great, but where do I start? Well, luckily they wrote a MEL to Python converter. It's called MEL to Py. It'll work on a single string, and if you run it on a MEL code, it'll spit out the Python to do it. It'll actually run on entire files and entire directories. Actually, I misspoke. It doesn't convert it to PyMEL. What it does is it just converts all your old MEL code straight over to Python code. It's about 95% accurate. Doesn't work on every little thing. Sometimes you have to debug stuff. And it doesn't necessarily turn it into PyMEL instance objects. It's pretty much just a straight up Python conversion. But it's a good way to kind of get going from MEL to Python, and then you can learn PyMEL later. So quickly, we do have to address the performance. So one of the few disadvantages people find with PyMEL is that it is a little bit slow. And the reason is because it's doing that API DAG path stuff underneath the hood. And essentially, it's doing a lot of Open Maya API calls. And it does get a little bit slow. So the trick is just not to use it on places you're not supposed to use it. Like vertex iteration. So you don't want to be iterating through 2,000 verts, or it works fine or something like that, but 20,000 verts on your character and with PyMEL, because what happens is it's essentially instantiating every vert as a vertex object. Now this is great because you have a vert object and you can run all these cool methods on it and you get all your stuff, but that starts to slow your process down. So for something like that, you're probably going to want to have to use regular old Maya commands, or better yet, API and C++. That's what that stuff is for. But only one script I've ever written has really gotten slow with PyMEL, and so if you can live with it for that one script, and to tell you the truth, most of the stuff we write isn't performance-based anyway. You're willing to wait 3, 5, or 10 seconds to have it automatically do all this stuff for you most of the time. Now, the PyMEL team is addressing this issue. They're trying to essentially educate users on how to use it best, essentially optimizing stuff underneath the hood and trying to avoid certain conversions. And they want to basically kind of collect more data for people, and so speak up when it's slow. And they work really closely with Autodesk to try and work this stuff out. So hopefully that addresses that. And so that's kind of the case for why PyMEL is better than Maya commands, but it'll really become clear when we get into the IDEs for the last section of the class. So a use case that starts to incorporate a little bit about what I talked about PyMEL is the concept of a Pythonized meta network. So for those of you who either went to see the super awesome end-all be-all of rigging talks called Modular Procedural Rigging in 2009, presented by David Hunt and Gibson and Steve Theodore, the Bungie guys, this stuff will make sense. Those of you who didn't, you've probably heard the idea of modular rigging, which is the same kind of concept. But this is a great talk if you can get a hold of it, and it's a great way to go. So anyway, this is a great use case to try and start using Maya commands, PyMEL, and object-oriented applied to this concept here. So I'd recommend getting that and converting it all over to Python, and then start to think about a class structure for rigging, and possibly even subclassing PyMEL's network class and make a special PyMEL meta network. And I'll expand on that a little bit later. So, I can't provide pseudocode or source code for this. I've done a lot of this already. It is possible, and when you start to do this, you're going to start to get some really amazing things, which I can talk about later if you want. But just kind of building it all up here. Okay, the last section of the class, IDEs. Any questions so far? How's it going? Good, bad? Too much talking? Too slow? Chat window's kind of slow. Can't. You guys okay? Can you see everything? Anybody left? 55 people, huh? Okay, so we are going to get on to IDE. So we're going to start with Eclipse. So integrated development environments are really cool software. If you're scripting a lot and you really want to start doing this stuff, I would start to commit to some serious software like this, because what you really want are some awesome features like code completion, auto-completing of your work, analysis ideally, and access to version control, and automatic check-in and check-out, and a bunch of other cool features I'll show here. So I would recommend Eclipse. It's free software as IDE, open source. A lot of people use it. It's heavily used by the Java community, kind of made for that, but there's C++ versions, and in this case, there's plugins you can add to it, and there's a plugin called PyDev that you can get at pydev.org, and when you free and add that in, it turns Eclipse into a Python powerhouse. It's a really awesome development environment. And there's a bunch of cool features it does. Now, the awesomest feature I can't live without is called mark occurrences, and what it is a really fast way to see what's happening with your code. So I'm going to show a quick demo of some of these things here. Hop over to my movie. Mark occurrences. Okay. So what we've got going on here is I have this variable. So I highlight it. And lo and behold, what happens is it highlights this variable in all my code. And, so I have a function here. It's returning this move all grip variable, and it's wrong. What's wrong with it? What happened to it? Well, I highlight it, and it shows me everywhere that variable is, so I can just look right up this trace and see what's going on with it. Now, the really cool feature here, Wing does this now, but it didn't used to. But the really cool feature that Wing doesn't do is you can't really see it real well. But over here on the right, on the column, it shows in yellow where all the occurrences of this code is. And so what you do is you just grab your slider over the side here and slide it up to the top where you want to. Where your code is first started, and sure enough, that's the first place that it was used. So you look up here and you go, okay, that's where it's being passed into my function, and then you just hop through and see all the different ways this is being assigned, and it starts to become really clear, how this variable changed. So this feature is super awesome. Once you get used to this, and I go to a different editor, there's, it takes forever. There's no way, like I'll open it up in the script editor or anything else, and I go, okay, what's happening to my variable? And I have to read all the code above it to see what's going on. That would take forever. I want to be able to click my variable and go, where is this and why did I do it? It's a super handy feature. You will love it. Okay, next feature, code completion. So this is kind of the bomb right here. So what happens is, as I mentioned it earlier, is when you combine the idea of the class-based methods that PyMEL does, what it does is it gives you any possible action that you'd want or query that you'd want to do on your object, and it gives it to you right there, especially with an IDE. This is super duper powerful. So I'm going to demo that for a good minute or so right here in Wing. So what we've got going on is we have back right here. Okay, so I have a joint. I have my joint. I've called my joint class. It's made a joint called test in my Maya scene. Now I have an instance object, and now this object I can run methods on it, like get preferred angle or get minimum rotation. So here's the cool thing. I want to do something else to it. I want to get some data from it or set some data. So I do my joint dot, and lo and behold, because IDE, it's all set up and it's all code aware. Dropdown comes back with every method I could ever want to do on this joint, and it's just huge. And so this is super awesome. So I want to find out if it's locked or not, and it's auto filling out and it's auto limiting. It's showing me there what my inputs are. I want to find the inputs and outputs. I type the word inputs, and if you'll see over here, it's telling me what is my inputs method. It's actually basically just the old list connections with source 1, destination 0, which I've typed a million times, but it's much easier to do with the inputs. Same thing with the outputs, a bunch of other functions here. So basically, list relatives, and it tells you what. So you've got your instance object. You start typing what you think you want to do with it, and your code, your IDE is going to autocomplete for you the name of the function that you're probably going to want to get your stuff. So I don't have to look at documentation anymore. No more documentation. I'm coding really, really fast at this point. It just allows you to code in a couple minutes. You just find the command you want to do. So my joint, it's all inheriting and object-oriented, so it inherits all the methods that a standard transform would do, like get, move, and translate, and that kind of stuff. But but because it's a joint and it's inheriting, it also has all the methods that are specifically joint driven. So all this set rotation order and set scale, all of these methods are attached to it too, because it knows it's a joint class and the joint class is inherited. And so I can do, okay, set preferred angle, that's the class I want, or one of these here, was set rotate. What did I pick here? Okay, set rotation order. I press enter, it automatically fills it out, it automatically gives me the arguments I want to use, and I'm off and coding away. So that took a minute or two because I was demoing it, but normally you just come up with the code you need to do really, really fast. So that feature alone, once you start coding all the time like that, there's no going back to like any other way as far as I'm concerned. Okay, but I have a bunch of other cool stuff in here like tooltips. It gives you a preview function into the preview window into the full function, and you can hop to it. So I'll do another demo right here of tooltips. So I have this function up here called, here we go, deep create base. What is it? I keep my cursor over it, and it highlights, and it says, oh, there it is. It's this function that lives over here. This is all the code that's in that function. That's the module it's in. Oh, I want to go over and manipulate it. You click it, it hops right over to your code, right where it is. And this is what you need. If you've got thousands of lines of code and hundreds of modules, you don't want to have to go find it. You just want to go look, preview into it, hop over to it as fast as you can. I'm told even Visual Studio doesn't even let you kind of preview into it. So it's really neat. That's a really cool function. Okay, auto importing is really cool. This is actually what they call context insensitive code completion. What it does is, because it knows about your Python path and your whole environment, is it's automatically going to tell you where stuff is and import it for you. Because Python's all modular based and importing based. So here's a quick example of that. So I'm typing away. I know I wrote a command somewhere that builds a hands rig. So I type hands, and sure enough, it says it's over in my meta rigging hands class. I press enter. It automatically imports it in the right namespace. Now I have my hands command. It automatically knows, gives me a preview to it. It knows what arguments I need. I press Control Space, and it just fills it all in for me. So it's super fast way to code. I don't have to think about it or know where stuff is. I just start typing, and it just imports it for me, and now my code is all aware. So really cool stuff there. Okay, next cool feature, code analysis. This is essentially it's actually gonna analyze your code and tell you whether you have undefined stuff, help out with your self declaration, tell you if you have indentations or syntax errors. It also does it on the fly. So it's code analysis? That's it. Here we go. Here's another demo. So you got some code here, you're typing away, you're a poor scripter and you type badly. So as you'll see right there, there's already a little red X, and it's already, you highlight over it, it says it doesn't know what this variable is. Once I define it, it's parsing it on the fly, error goes away. I try to do a for loop, I accidentally type it wrong, I put the word into in there, I do other stuff wrong, and already it knows. I highlight over it, it says I need the word in here. It tells you, okay, this is easy to correct. I think it'll actually auto-correct that for you too if you type the right word. That goes away. At this point, I highlight over. It's giving me a warning. It says it's bad indentation because you need to tab it in. So it fixes it all right there. That's really handy. What this means is that before you try and run your code, you just look in the column. If there's any red or yellow, you fixed it. It's essentially going to do syntax error fixing. So right here, it automatically knows there's an extra parentheses, and I fix it. So at least if you look in your column, there's no errors, your code is going to run without syntax errors. Your logic may be crap, but at least it's fixed the basic stuff for you. So that's pretty cool. Faster the better. All right. Can everybody else still hear me? Okay, fine. Some people are still good. Okay, finishing up with Eclipse. The outliner is really cool. It has a lot of bells and whistles and hierarchy. I won't demo it, but it's super powerful outliner. You need to have that stuff if you're jumping around thousands of lines of code. So that's really cool stuff to have as well. There's also my editor. Some people like to have their script editors talk back and forth with Maya, like PIML Studio Pro. There is a little plugin this guy wrote. All these links are at the end, and I have them on my blog too. So no, I have not hit mute. Everybody else have sound, I hope. code completion. So the question is, what do we have to install for code completion? I will talk at the end. There, my buddy Christian made a site called Making Eclipse, or you can look at it at Google, and it has, and there's also documentation in PyMEL how to get autocomplete and code complete. But it is tricky to set up, but it's worth it once you do it. I'll talk more about that at the end. So anyway, there is this plugin that makes Eclipse talk back and forth and spit into Maya if you want to. Okay. Finishing up with Eclipse, it does do real-time debugging. In other words, you can grab your Maya process. It's not the best implementation. Wing IDE, which I'm going to talk about next, does it a lot better. So I'm going to show those features there. The Wing does cost a couple bucks. If you don't want to spend that money, you can do it in Eclipse if you want to. And I made a blog post. If you go to my blog, I've made a blog post on how to get it hooked up in Eclipse. Okay, to summarize, for Eclipse, it's all about the environment. Eclipse is totally aware of your whole code base, and when you have auto completion set up, and what that means is everything you type is either a string or code aware. So you can't type anything that isn't code. So if it's either been imported, or if not, it knows where that function is and it will import it for you, and then you can hop right to it. So it's totally aware of what all your code is doing. This is really an awesome concept when you start to use it and think about it. It's a fast way to program, and this is a real professional's tool. This is the kind of stuff that all those engineers are doing, and now it's finally available to us scripters. So the sooner you can get on it and use it, the more fun you're going to have, the more power you can do it. Okay, so one quick use case, pseudo concept, and then we will finish up with Wing and debugging. Okay, I will check with questions a little bit more. Okay. So our use case is the concept of rigging classes. So what would be neat if you did rigging is if you started to kind of make a class system for kind of your different rig components. So you could start with a basic rig, like a basic class that does a standard FK control, and then you could inherit off of that and make subclasses and make them more advanced, like a simple FK chain or an IK chain that inherits from that, or a specific type of IK chain that would inherit off of that. Let me adjust my window here a little bit so you can see it better. Here's an example of kind of how that would lay out conceptually, right? You can make a class. So with classes, you can inherit code, so you can make a base class here, and you can make basic chains and kind of generic chains and IK chains that kind of build off of that, or a more specific, you can make a leg rig that inherits from your basic control, or a biped or a quadruped rig that inherits from that. And I actually was going to show a little bit of pseudo code for what that would look like. And here it is. So for those of you who want to look at this a little bit, here's a little bit of example. It's not fully fleshed out, but the idea is you have a class with a base control, and you pass in what control, what joint you want to control and what your control wants to be on it, and you assign some attributes to that, and then you would call a build method, and it would essentially, in this case, just parent the control to the joint. So that's a super simple FK rig, right? But the cool thing is with OOPs, you can inherit stuff. So you can make a basic leg class that inherits from this base control class, and it can do everything there. And so what you would do is you could make a class that does that. You could call a leg control method, and what you would do is you would run the build method. Now this build method is inherited from this, so it would parent the control to the joint, and then you could do whatever else you want. In this case, it's just going to hide that control, but now you could say, build more of my leg. And then you could go down further and make an actual biped leg class, and it would inherit from the basic leg class. In this case, you want it joint, but you want to maybe pass it a bunch of different controls. And now you have a method in here, so you can instantiate this biped leg class, and you can run a method called build biped leg. What it would do is it would iterate through the controls, and for each one of those, it would run this leg control method, which essentially runs the build method from above, and you get the idea, hopefully. So this is just pseudocode, but this is the idea, and this is how it would be called. You'd do leg rig, and you call your class, your subclass here, and you pass in your arguments, your controls, and your joint. And then you have your instance argument, you say build it. And essentially this would kind of daisy chain up and do everything you've coded here. So you can tell that if you did that on a bigger level, you could start to make all your rigging do that. And it's pretty cool stuff. Okay, let's get into the wing. Let's finish up with wing. And we only have about 10-15 more minutes if I talk fast. And hopefully you guys will make it through here. So this is some really great stuff too. Okay, so Wing IDE. You can only code Python in it. It's made for Python coders. It has a lot of nice features in it, though it does run a little bit slow and clunky. But if you can get used to that, and you don't want to have to use Eclipse and Wing, you can just use Wing for the most part. I like to use both. It's perfectly fine. You have both open. I alt-tab between the two. They both update each other if you're editing code in it. It does cost a couple $100 for the Pro version, and that is the one you want because that's the one that allows you to do debugging. But $200 is nothing, especially if this is your job. Your company should definitely pay for it. So, Wing's killer app. It does a lot of what Eclipse does, and not everything what Eclipse and the PyDev extension does. That's why I use Eclipse. But what it does really well is its real-time debugging, which will totally change your life as a Maya programmer. And it's pretty hard to describe how awesome this is until you use it. As a famous hacker once said, some of you have heard, it's impossible to describe what the matrix is. You have to see it to believe it for yourself. So I'm going to try and demo it a little bit, but once again, until you see it and use it for yourself, you really won't know how awesome this is. So, quick cover of the old way. Debugging the old way is totally sucky. You have to use print statements everywhere, comment them in and out, make a clever little UI prompt that shows you what's going on. And it's a really slow way to go. No fun at all. And at some point, you really just can't figure out what your code's doing too much until you start to use this. So if you want to do real-time debugging, remote debugging in Maya, you basically start Wing in Maya. I'm going to show you examples of this. You establish a connection between the two with a little bit of code. I think I posted it on my blog, and there's other places that have it. You set a breakpoint your script in your Wing, and then you run the script from Maya, and Wing is going to grab the process and halt Maya. And here is the demo. Here's my screen capture of it, and I'm going to hop over to Wing Simple. Okay. So what you've got going on here is, hopefully you can see all this. Okay, so we have Maya on the left. Let's scoot this a little bit so you can see all this. And Wing on the right. And I have my script open on my right. And I have a little breakpoint set where that little red dot is. And I'm going to import the script and run it from Maya on the left, and it's grabbed it and it's run. That red line there, Maya has halted at this process, Wing has grabbed it, and I'm at that line, and I can step through with function keys and F6 my way through this code and hop through one line at a time, and you see the data being updated on the right over there, and you can put your cursor over that data and see the value of those variables at any time you want. And then you just continue through with your code, and it finishes up. And it just returns the process to Maya, and it printed out the data over here. So that's how a simple debug session happens. And so what you can do is you can set breakpoints. You can do watch variables, which is a way to put a variable in somewhere, and it'll evaluate that variable every frame for something you really need to pay attention to. You have this debug probe in Wing, which is really cool. And what it is it's a live Python interpreter right there at the state of your environment. And it has autocomplete in there, which is really handy for reverse engineering instance objects of weird classes that you don't know what's going on. I'll explain that a little bit more. And then you have the call stack, which allows you to see what functions led to your current spot. You can hop up and down the call stack. So I'm going to show you another demo of this stuff happening. I think it was, which one was it? Was it probe? I think it's the probe. Let's see if it's this one. So what we've got, no, it's the other one. Hold on, my bad. It's the call stack. Okay. So what we have going on here is same thing. We run the code. And over on the right, we have You have your stack data, so you can see, the value of all the variables. You have your call stack, and if you're like eight levels deep into your script, you need to see where the script came from. And you can press function keys and hop up and down that call stack. In other words, which function called which function, and all your variables in your stack data all change and update as you go up and down that call stack. So you can see how variables change as you're moving through it and what's breaking it. And as you see right here, I expanded my stack data. I know it's small and you can't read it, but essentially this is the value of every variable that's at this current moment. And you can expand into the lists and dictionaries and see all the data that's going on in there. And okay, that's that one. I think I may have got these out of order, but you'll get the gist of that. Yeah, so this is the slide for that stack data, all that stuff I just said. You can hop up and down, you can look at the stack, you can reverse engineer obscure code, and I'm going to show them slightly out of order here. I apologize. So this is the debug. You're getting all the Wing features me summarized here in as quick as I could. So what this is this is going to show this debug probe down here, right? Okay, so I've stopped my code, I'm stepping through it, and I'm not really sure what's going on here, and I want to test stuff. So what I do is I hop in down in this debug probe, and this is an interpreter in my Maya session live right here. So I can start printing stuff out, the value of variables, and it's doing autocomplete in here. It has full autocomplete. It knows what my environment is. So I can create objects in this case. I'm making like a joint, and when I press it, you see it updating over here in Maya because I have this little refresh trick I'll tell you. But this is really cool if, let's say you download a module that's like some XML parser converter, or some package from somewhere, and you instantiate the class and you have an instance and you're like, what does my instance object do? And what you can do is you can go down the debug probe and you can type your instance object and do dot and see what the autocomplete does, and you can see what all the methods are that are attached to it. So that may not sound important, but all these tools here are really handy and really cool way to see what's going on in your environment. So normally your Maya process is frozen. There's a little trick though, because you guys probably know about the old mel command refresh. It works in Maya too. If you put that in your watch variable listing, what it means is Wing is going to eval that at every frame, so it's going to update your Maya UI, which is kind of handy because sometimes you want to see your UI updating as it can line by line. It doesn't update everything in Maya. The outliner doesn't open, but it will update your viewport if you want to see your rig building or something like that. Wing also has cool unit testing tools. If you don't do unit testing, but you've heard about it, think about getting into it. It's ways of doing testing and pounding on your low-level code. When you do that, you want to kind of batch auto have your unit tests run. Wing has all these cool functions to do that for you really easily, and it's really, really cool. So to summarize Wing, we're just about done here. You're going to want all these professional coders features, all the stuff we saw in Eclipse, debugging breakpoints, stack trace, but the runtime debugging, hooking up to Maya, this is the most important ability I've talked about during this whole class. This is going to allow you to iterate really quickly. This has really changed the game for us as far as scripters go. This really turns you into a programmer and allows you to build really large, elaborate, complicated code bases that do pretty much whatever you want because you can dig in at really low levels and see what's going on in your code. Okay, so we're going to summarize with a final use case. It's pretty pie in the sky. It's very philosophical. Kind of combines the use cases I talked about earlier. But it's an interesting idea, and I wanted to leave it with everybody so you can take it and run with it, and we'll see what people make out of it. So we're going to bunch of text here, but you have the rig classes we talked about earlier, and if you combine that with the concept of the meta networks, for those of you who know about this modular rigging, this is what's possible. So you have meta nodes. So the meta network has meta nodes, which are little information nodes hooked up to your rig bits. And they are like brains for your rigging components. So you have a little meta node hooked up to your leg rig and your head rig and your hand solution or whatever. They have all these connections, and they're kind of like little brains, and they know everything about these rigs, and you can call these and get information from your rig bits. Now, if you connect all these meta nodes together, you get a big central brain. And essentially from there, you can go down the rig bits and find out any of the information you want to about the rig. And in many ways, this is kind of a nervous system for your entire rig. Now, the code to build your rig is you probably used, if we've used what we talked about already, you use classes and instance objects, and you've created instances of your leg rig, and you've run legrig.build, and it's built all that for you. But now when you run that, that code is gone. It finishes the rig and it's made up that meta network, but that instance is gone. But while that instance was running, or your build code that's doing it, that instance has a bunch of methods on it that lets you tweak and change stuff on the rig right before it's being built or right after it's being built. Now, like I said, that instance is now gone. Your rig is static in your scene. You have this nervous system that you can query, but the code to build it is just in your code library. Now, what if you could embed that instance object that made the rig bit into the meta node, into the little brain that was connected to that rig? That would be pretty interesting. You could probably do something like this with the pickle module or other ways of doing it by essentially embedding the code into the rig that made itself. And what this means is at any time your rig is in your scene and it's working, you can query the meta node that's hooked up to that rig bit or the brain and essentially retrieve the instance, the code that created it. And you could do some stuff with that. You could run methods on that instance. Stuff like delete that part of the rig, or change it, or alter it, or recreate, delete it and recreate it, or update itself, or even animate itself, or do kind of whatever you want. So what that means is kind of the rig is aware of the code that made itself, and you can run live code on rig bits. And it's definitely possible. Can this be done? I think it is. It's definitely not possible to do in MEL, right? This requires instance objects, and you're probably going to want to use PyMEL to make all this readable, because this is going to be a whole bunch of code. You definitely need classes to do this and objects. And you're definitely going to need a big idea, integrated development environment to keep all this code straight. I can tell you this because I've done stuff like this, and this code's going to get really complicated. So you're definitely going to need to have real-time debugging like Wing and Eclipse can do in order to make this work. So this is kind of a use case of why you would care and try and make this whole development environment. So why would you need all this? Well, theoretically, it's possible to make these rigs that do really amazing things, but in order to do it, you're going to need to be working at a level like this. So that's my use case for why you'd want to put all this stuff together. Okay, so let's finalize. We're almost done here. To conclude, in my opinion, the three most important things that happened in our digital content creation apps in the last 12 years was when Maya was released. I enjoyed playing with a beta way back when, and because it's all built on MEL, it kind of changed the industry, as we all know. When Maya added support for Python, I think it was like 08, it didn't seem like a big deal, but it really wound up being bigger than they knew it, because it allowed you to plug into every Python package on the planet, and it allowed somebody to write something like PyMEL and turn it into a real class-based command system, so you can really do whatever you want. That combined with these IDEs that are super powerful, aware of your code base, and connect into Maya in real time, this is a big deal. We're on a whole new level. That's what I think. That's my opinion. So these are some people I need to think about it. My partner at Sony Online helped me develop a lot of this stuff, Christian Akeson. You can follow him on Twitter. Seth Gibson is definitely the man you want to follow on Twitter at VO Method. The guy tweets all kinds of tech art stuff all the time. Great guy to follow. I need to thank Eric Pavey, the guy who originally did the post on how to connect Wing to Maya, because once I've been debugging that way, I've never been able to, I'll never go back. And it means we can write incredible code now that we never could before. Chad Vernon for letting me show the CV exporter stuff, and of course you guys know Rigging Dojo. Those guys, Brad, Chad, Josh, all those guys do an awesome job. I stopped following like all the 3D art sites, and I just follow my Twitter feed, mostly Rigging Dojo, and that's where you get all hot rigging tips, every day. All right, that's all I have for you. Thanks, everybody. Time to do questions. At this point, I took my drink and pause, and people at GDC clapped a little bit, but can't do that here. So you can follow my Art of Tech at Twitter account. Thanks, guys. Awesome. It's where I do all my tech art posts. I still have my other account 01 where I need to start doing a little bit more crazy streaming stuff. I bought this domain. I'm trying to do some regular blog posts there. And so write that stuff down. At my blog, you can get a copy of the GDC talk that I gave, and I'm going to try and put up the source code that I didn't really get to show here, some of the source code for virtual classes and array classes and pseudocode and that stuff. These are some of the links here. Can't read them, I guess, but you can get it if you download the PDF from my blog. You'll get links to Christian's Eclipse setup page, the CV exporter, and Wing connections and stuff like that. So if we want, hop into this mode, and you guys can ask more questions. Sorry I didn't pay attention to them as much as I was talking, but it did take an hour and a half, and I still skip stuff. But hopefully that will get everybody up and running. There's questions right there. I see text questions. Are API DAG paths for nodes only available on the run of the tool or script, or always accessible? That's a good question. So you don't have to do it while you run the script. You can, in your script editor, you can use standard Maya commands to kind of do Maya API DAG path stuff. You get it when you start doing PyMEL. When you instantiate a PyMEL object, or you wrap anything you've made in Maya with a Py node, it'll class it for you automatically. So let's say you've got a sphere in your scene, and you can just say, my sphere equals your sphere Py node, and you put in your sphere, the text for your sphere, and now that variable is an instance of it, and it's attached to the API DAG path of it. You can do whatever you want there. Hopefully that answers Meatpaw's question. Next question: is there a reason to use Eclipse if you have Wing? Yeah, great question. Like I said, some people just like using Wing. I like using both. Eclipse is better and bigger in a lot of ways. That key feature mark occurrences, I asked the Wing guys to add. They did. It isn't implemented as well. You can't see it as well, but you're fine using Eclipse if you get, or excuse me, just Wing if you're getting used to it. But I just like Eclipse more. It has better features. It's more powerful. It can all the auto importing. Using both is fine. So you can use one or the other. I use Eclipse for all my stuff when I need to debug. I hop over to Wing, and then I just alt tab back and forth. So it's up to you. So last question so far, not much of Python Q, but any good tips or links where how to learn regex? They look so complex. They sure are. There's a couple, so the question is regular expressions. There's a couple like little regular expressions widgets you can get. I have one, I forget what it's called. Maybe I'll put it on my blog if it's not there already. But what it is this little, executable you can run on your Windows desktop or whatever. And it lets you kind of put in your string you want to be parsing through and screw around with regular expression code, and kind of gives you some hints there. And it kind of live updates on the fly what that would actually grab from the regular expression. regex, nobody's ever going to get it. It's one of those weird double-edged swords. I mean, everybody needs to use it some, but anybody who fully gets it is spending way too much time coding as far as I'm concerned. You use it when you have to, and I kind of hope I never get too good at regex. Any other questions? Now is the time to grab me. Cool. The idea is of cool scripts we can write to learn PyMEL. Any script is good. So if you don't have anything, if you're still in MEL, start using the MEL to Py converter. It's a tool under PyMEL, and just get all your favorite MEL scripts over to Python so you can start to look at that and use that. Then what I do is start going through those and trying to make them look prettier and cleaner using the attribute class, right? Instead of using getAtter, like start looking through the PyMEL docs a little bit and use the joint dot tx dot set 5, that's setting the translate x. So I'd start using it that way. That, and try and start to use the PyMEL classes. That's the real. Now there's dozens of other cool things PyMEL does that I didn't get into, and they're just all this cool convenient stuff. Go to the PyMEL page and it lists all the cool stuff you can do. But the real silver bullet is the classes stuff. So next time you need to do any kind of Python or MEL code, let's say you want to change some normals on your sphere. So what you do is create your sphere with the sphere class in PyMEL, or use the Py node to essentially convert your sphere that's already made and have now into a PyMEL instance. Now you have your sphere and it's a PyMEL instance. And what you do is in Maya 2011 will autocomplete a little bit. So in the script editor, take your sphere dot and then start typing something like, what do you want to do? You want to change the normals. Just to dot normal or dot get normal, or go to the PyMEL documentation and look up the sphere class, and you'll see all the methods that you can do to it. And it's pretty much all the standard Maya commands you would do to it, plus a whole bunch of other convenient stuff that PyMEL has wrapped that probably does what you want to do right away. So you'll probably do sphere dot get normal tangent, and then you try that, and it's going to spit out your value. So that's what a good way to start using PyMEL is to start making classes of everything you have in Maya, and anything you want to do, start figuring out the methods that are attached to those classes. I hope that's a good way to start. Okay, next question. Having only used MEL and Maya, how do you deploy your scripts to artists, Maya menu and Python? Well, we use Perforce as version control, so all the artists get latest and they get a copy of all their scripts locally. We tend to actually push all of our stuff to a network drive, and we have legacy MEL code that makes a menu in Maya, and just the menu words are commands that just call your Python scripts. Christian, my buddy, just actually rewrote it all in Python because we were sick of using the MEL. So it's essentially a Python script that gets run in your user setup, and it makes a little Python menu, and each word command in the Python menu imports and runs the command. So yeah, every team needs a tool distribution mechanism. Any other questions? Still 50 people here? Really? Anything else? Great questions. All right. Thanks all. I need to take a quick break. If you want to hang out, we can chat for a little bit and or ask any more questions, but I'm going to run outside real quick. I'll be back in 3 minutes. Thanks. How would I set up PyMEL code completion in PyDev? Yeah, so no, it's not automatic. It's definitely going to take some work. So the top link you see over here, Christian's page on making Eclipse SOAR. So if you go to the PyMEL page, they give you instructions on how to set up Eclipse, autocomplete. Christian has more instructions. There's a continuous kind of thread and need. It can be a little bit tricky, but it's worth it. You want to pound away on it for a while. To be honest, even when you get it set up, it'll kind of go bad on you every once in a while. You kind of have to refresh the interpreter or reset it up. But once you've done it a couple times, you get to set it up, in a couple minutes, and it'll kind of stabilize. So it is tricky, but it's worth it, of course, because you're setting up this whole environment, and Eclipse becomes aware of your whole code base, like I said before, and everything you're typing is a command, and it auto imports it all. So it may even take you like a week to I kind of got it to work once, but I had to adjust my memory thing. And there's, if you Google it and look around, and you can email me or go to the, techartist.org is a good forum, or, search around. It's doable. It's done, but it takes just a little bit of tweaking setup, but it's worth it. I mean, it's a total small price to pay to get into the big leagues. So go to Christian's site, Making Eclipse SOAR. You can Google it right now, and he has instructions on not just setting that up, but all kinds of Eclipse goodies, a bunch of XML plugins, and all the PyQt stuff. So PyQt is awesome. Really hard to kind of get set up in Maya and Eclipse, but he's figured it all out. All of his UIs are already written in PyQt, and he has all the auto-completion, everything working in Eclipse, and he's got all the exact installs and executables for 32-bit or 64-bit and how to install all that stuff. So Christian's written all that stuff up. Okay, next question. Is that Python deployment code proprietary? Which Python deployment code? Oh, my menu thing. Yeah, we wrote it at Sony Online, so we can't give that out. There really should be like a like a code menu tool available, but I can't think of any really available like at Creative Crash or anything like that. Maybe that's like the price of entry to be a tech artist for your team. Like the first thing you got to figure out is how you're going to deploy your code to your team. If you can do that, then you have the right to write your code. I don't know what to say. Anybody else have any ideas? You want to throw it in the chat window? We can't release ours, sorry. Osipa's UMen makes a menu. Yeah, Jason Osipa released some pretty good stuff. I tried it. I couldn't necessarily get it to work real well, but I think Jason Osipa, it's called UMenu. Yeah, that's probably a good way to go. All right, any other questions? Scroll back up here on the staff questions. Is there a PEP discussion? Okay, yeah. So there was a bit of a question about PyMEL core import, different ways to import Python. Can go into that a little bit, I guess. How you want to import it. You're supposed to import PyMEL core. You can do PyMEL all if you want to. And how you want to input namespaces. Some people use the PM, into namespaces. It's a matter of preference. I tend not to use namespaces, but, sometimes I do. All right, any other questions? Cool. All right, well, thanks everybody who's still hanging out. Thanks for listening. Get up, rigging. This is an awesome way to go. There's really no limit to what kind of tech art tools you want to make once you start using Python and PyMEL and classes and IDEs. It's strictly a matter of time. I mean, you can make anything you want pretty much. So any other, if you're using any other packages, or if there's anybody else, any other software developers out there listening, if you use Python as a wrapper for your SDK and you expose that Python interpreter for an external debugger, you can have tech artists writing awesome tools and art pipelines just like we do for Maya. This is a speech I gave to a lot of the next-gen developers up at GDC. So some of them are listening and they're exposing their Python interpreter and or adding Python wrappers to their tools. So hopefully we'll be able to do super awesome stuff like this with all the DCC apps someday. Qt resources. I'm not the big Qt guy. Christian Akeson is. Go to his blog post, Making Eclipse Soar, and there's a decent amount of talk on it on techartist.org forum. We all hang out there. If you don't, you should definitely join us. There's a continuous Qt threads and posts going at techartist.org. All right, I'll see you there, Mr. Penny. Favorite Python module for handling XML. The latest is XML tree. Guys love. I used to use like this free one called Chillcat. It was too much for what I needed. Then I moved on to the standard XML mini DOM because I finally figured it out. It wasn't too hard to use. But Element Tree, that's it. Element Tree is the latest one of choice. Super fast, which can be important when you're scraping and parsing tons of XML stuff. So I would look into Element Tree. Autodesk released from GDC on Qt. There was a big thing, Autodesk released from GDC on Qt. Didn't remember seeing anything about that, Mr. Newman. Yeah, Mr. Logston, Element Tree, Seth Gibson told us, it's the latest cool thing, and Christian did a whole bunch of it, and he loves it. It's working out real good now. Cool. Love geeking out on the Python talk. Any other questions? Still doing motion builder stuff. It's actually been a while. I've had to dig back into it and had to look into my old master classes to see how to do stuff. I've done a little bit since we're using it on some of our new projects. Oh, and I did get Wing to connect to Motion Builder. Actually, I did it again today. So with a little bit of pseudocode, you can debug your Mobu scripts with Wing also. And I put a post on my blog about how to get that going. That was really cool. That made my day back when I figured that out. And I knew I had to start coding Motion Builder again because I was so spoiled with Maya. So you can do it with Mobu. It doesn't have PyMEL, though there is a guy writing PyMobu. If you look it up, I've got it. It's really early implementation. I mean, I applaud the guy for it. It's just some low-level basic stuff. But it's open source. We can all add to it. And I knew if I had a project that I had to continue to contribute to, I would probably start working on the PyMobu with him. But the Motion Builder Python implementation is really like the Python API stuff. I mean, it's all just API wrapped, so it's a bit harder to use. But what was I going to say? But it is really nice having the debugger to look into it. It's a good step. So Mr. Newman posted a link to class 3. Using Qt Designer for MEL interfaces. But yeah, I think Christine or somebody did give some talks at GDC. I didn't get to see that one, but Qt is awesome. I mean, it's PyQt is the way to go for interfaces in Maya for sure. Because you have the whole designer, you can design it all in the external designer app and port it all over and stuff like that. Thanks again, Mr. Robbins. You too. Have a good one. All right, thanks for the links. All right, any others? Thank you guys. Okay, we might as well sign out. You guys know where to find me. Post a question on my blog or follow me on Twitter or lead to me directly.
Thanks, Jason. I appreciate it, and thanks everyone for coming. We'll get the video up as soon as we can. Get it first, and then we'll link it out when it's available. All right, thank you guys. Have a good night.